It's my pleasure to share new roles for antifreeze protein and their potential applications. So antifreeze protein are generally found in freeze avoidance organisms. So with regular antifreeze, they deprive the freezing point of water in the organism so that they do not freeze. Antifreeze protein are very diverse molecules. They have very different structures in different organisms. So shown here are several different types of antifreeze protein in fish and insects. And based on, there are two well-known properties of antifreeze proteins. Antifreeze protein can modify the ice shape from a hexagonal shape to bipyramidal shape. And antifreeze protein can also inhibit ice recrystallization. Shown here that we can see antifreeze protein can inhibit small ice crystals grow bigger. So based on these well-known properties of antifreeze protein, they already have many potential applications. So antifreeze protein can be genetically engineered into crops, prevent frost damages to these crops. And also antifreeze protein can be directly added into storage buffer to preserve organs, tissues for transplant. And antifreeze protein can be added into frozen foods, such like ice creams, to prevent loss of the quality upon freezing. So what we have done at Castle LA, we focus on the recognition of small molecules, non-ice-like molecules by antifreeze protein. So by correlating the molecular structure and the function, we found small molecules that can enhance the antifreeze activity by 10 times. And also we have discovered new roles for antifreeze protein in inhibiting the crystallization of non-ice-like molecules, such like nucleosides and carbohydrates. So these have been reported by Chemical Engineering News and published in TNS. So I'm going to talk about the potential applications only in the pharmaceutical industries. Nucleosides and their analogs drug ingredients. However, nucleosides tends to crystallize in needle-shaped crystals, so which has poor solubility. So with the use of antifreeze protein, the crystallization of nucleosides can be completely inhibited. So the amorphous nucleosides form, which is the improved solubility of the drug ingredients. And by changing the experimental conditions, we can change the crystal shape from the needle shape to the block shape. So the block shape antifreeze protein, the block shape nucleosides will be easy for the transportation. This is just one case. Okay. So excipients such like carbohydrates and salts used to stabilize the therapeutic biologics. However, the crystallization of excipients can cause the valve breakage. So by using antifreeze protein, we can inhibit the crystallization of mannitol, which is a common excipient. So these valves are bottom up, so we can see there's no crystal form in the two valves in the red rectangle. Enzymes are very useful in pharmaceutical industry. However, they have very limited stability. So antifreeze protein can not only stabilize the enzymes under freeze condition, and also stabilize the enzymes at a high temperature. So to summarize, AFP recognizes a wide range of molecules beyond the ice, and the new roles for antifreeze protein expands the potential use in pharmaceutical industries. So I would like to thank all the past current lab members and our collaborators. They are wonderful people, and the funding from the grant agency. Thank you all for listening.
Hi, everybody. So today I'm going to talk a little bit about worker cooperatives as a strategy for racial justice organizing and what is the next system. So what is that? So a question is, how are worker-owned cooperatives potentially agents of racial justice? What is the relationship between racial justice organizing today and creating the next system, creating worker ownership and workplace democracy? You can see a couple of examples from Cleveland, Ohio, and Queens, New York. We look back and know historically Black communities, Black organizers have been engaged in economic cooperation to endure the oppression of racial capitalism for hundreds of years now, 200 years of enslavement and civil rights organizing. We know that capitalism is a deeply racialized and patriarchal system. About 20% of us in the world do pretty well with it, 80% of us immiseration and continued exploitation. So that's another part of the back piece. 50 years ago, Martin Luther King Jr. talked about the triplets of materialism, racism, and militarism, and now we can add the ecological crisis to those triplets. We also know that the earth is finite, capitalism is expansionary, and the continent of Africa is going to be hit especially hard with climate change. We also know that we continue as a country to not historically reckon with our history of enslavement, racial terror, genocide, etc., and that axioms about revolution in the 20th century have proven not to be self-evidently correct. The idea that you take state power, then you change the system, or that the labor-capital conflict is the only one we need to deal with. The other axiom that democracy is bourgeois, we know that that's no longer true. It's a profoundly revolutionary anti-capitalist idea, and so on, right? And again, the human consequences of capitalism, the ecological consequences we need to deal with. So sociologists and others are pioneering a field of next system studies to say the crises are deepening, scholars and teachers have to move beyond a critique of what is to imagining the next system, right? And that we can also empower students who feel like, what can I do about any of this, right? Contemporary racial justice organizers agree the movement for Black Lives Matter is, with cooperatives, is demanding support for cooperatives. Here's a couple of examples. Cooperation Jackson is incubating co-ops in the South as a strategy of racial and economic justice. The Dream Defenders in Black youth-led organization, next slide, in Florida, has created a worker-owned apparel co-op that they describe as a revolutionary alternative to capitalism, where people own their own labor. So that's one of their t-shirts. I've been to the future, we won. And they say this co-op represents the revolutionary agenda of young people of color. There's no sweatshop labor here. And we're attacking the system by building alternatives. I've been part of a project, Lucy, we co-founded in 2015 to create that kind of model in Los Angeles. And our goal, there's 6 of us who are co-founders, is to create social and economic justice here. Unionized cooperatives in particular build on the institutional strengths and democratic organizing experience of unions. The idea is to also generate new subjectivities among worker owners who don't need bosses. Here's the union co-op model. And let's see. There's too much here, but that gives you an idea. But you can sort of see that you can be a worker owner and also be a union member. Our first project, which just won an award from Mark Ridley Thomas's office, is the Vermont Gauge Car Wash. Here's my plug. Please go get your car washed in South LA there. The immigrant workers there, who are now worker owners, experienced wage theft. The owner up and left the country, owed them weeks of wages, and now they're worker owners. Our next project, Nikki O'Cook, is one of the members of Lucy. She said she's the boss. She's the owner of RCO Tires in Compton, and she says, fire me, fire the boss. So we're going to convert RCO into a democratic organization workplace. We know that worker ownership in the next system can weaken the grip of centuries of racial capitalism, begin to repair the future, even though acknowledgement of the real histories of the past hasn't been accomplished. We can still work on that. And in curricular terms, it's really important to help students develop a forward-looking sociological imagination that critiques the exploitative structures we inherit from the past, but also imagines a more just future and takes steps to enact it. Thank you. Sorry.
Understand causality. What buttons can you push on one side to get an outcome that you desire? Now, I do that in my lab, I do that in my classroom, but why don't we turn that powerful lens like a laser upon our students to improve their outcomes, to improve their academic and and psychological outcomes? And so one of the things we've been doing is trying to think about what are some things that we could do that could easily be adopted for this framework? And I want to ask you to join with me on this vision. I want to cast this vision for using this powerful tool as scientists and to be the forefront of using randomized controlled designs. So I'm going to present to you a little bit of data that we've already collected from a study with 200 students. And we've really done this in a really small fashion. It was just a pilot study. And this is really small, but we randomly assigned these 200 incoming freshmen to condition A and condition B. And 3 months later, we have a significant improvement in GPA in intervention B. Now you must be asking yourself, tell me more about intervention B, right? Because intervention B, what it turns out is, even when you control for high school achievement, high school GPA, we still have a significant effect. And so what we did was we focused on social belonging. We talked a lot about equity and improving equity yesterday. And we focused on social belonging because there's a lot of data already out there from these small studies with 30 black students at Stanford. And I'm very happy for those 30 black students at Stanford. But we need to realize that real intervention means massively scaling up to the 30,000 students we have at Cal State LA. And so we just tested one idea this summer, and we had these incredible, amazing results with our 200 students, but we don't want it to stop there. We actually know that a lot of the different ways we could improve social belonging also has this very terrible edge. You could activate stereotype threat. So just because you do social belonging interventions doesn't mean that you'll get the outcomes that you want. You might actually do something very damaging to our students. And so what we realize is, all ideas are only good, but implementation is really what's important, right? And what we're doing here is implementation. So why not more randomized controlled designs at Cal State LA? That's really why we need that comparison group, so we know that our implementation works. Well, one idea might be, we're smart people, we know what to do, we just implement it. But come on, guys. That's not us being scientists, right? That's not us caring about the data and real results and real outcomes, right? I want to suggest another idea that's maybe unpopular but probably true. It's really just too hard. It's too hard to do research. None of us got time for that. Ain't nobody got time for that, right? And so it's just too hard to do. But what if it was easier? What if we built the structures that we need to help us do randomized controlled designs in an easier way? We have this whole department called institutional research that collects data on our students like all the time. Why aren't we using that data in a methodologically sound way to improve outcomes for our students? So I want to suggest that we should be involved in building the infrastructure not only within our college but across the university to be the forerunners of really thinking about how can we integrate data into our daily lives. Wouldn't it be awesome if we could do that? Right now, we're doing a project to build that infrastructure into the introduction to higher education classes, to build these online homework structures where we could deliver in a randomized controlled fashion interventions that we believe might help students. BNE has signed on. They were really fast about it. HHS and engineering are also involved. And we've been talking to Nancy McQueen and lots of people at NSS, and hopefully NSS will be not only just participants, but we will be the forerunners. We are the ones who kind of own the scientific method, for better or for worse, right? So, we should be the forerunners. We should be the real think tank to really think about using this tool for our students. And this building infrastructure idea, this is really just the beginning. So I really look forward to talking to a lot of you guys about your ideas, how to get them tested, how to build the infrastructure so you could test those ideas better, right? So thank you so much. For more, I know this is a really short talk in a weird format, so please email me for more information or talk to me today. Thank you.
Today I'll be speaking about a kind of traditional healer known as Bori practitioners found in northern Nigeria and southern Niger that only a handful of anthropologists, including myself, have ever worked with. We rarely study Bori practitioners. In Muslim Hausa in northern Nigeria utilize spirit possession for therapeutic and healing functions, but also use spirit possession for non-therapeutic cultural phenomena and performance. The new dynamism of religious fundamentalism in the north, particularly the rise and spread of Boko Haram, has further marginalized the Bori. Although Islam is ingrained in Hausa society, the Hausa people are still invested in their indigenous identity. Bori practitioners suffer or endure tremendous social inequality, but they manage to persist because they effectively combine elements of Islam and traditional Hausa culture as part of their therapeutic practice. The Hausa people are menaced by thousands of different spirits. You could be a farmer, and there are spirits in the bush surrounding you. They're everywhere. You can be caught by a spirit when you cross paths in the bush, at the market, while you're farming on the road. You can inherit a spirit from deceased kin. And when you approach a village, you'll see goats freely walking about outside the village walls. They believe that these goats will protect them from the spirits that are there. So the goats are out there foraging and protecting while they forage, and from an ecological perspective, it's a good strategy. You don't have to spend so much money on animal feed. Just let them forage and they come home at night. This is a picture of some of the women in the village. The Bori women are older, and they live on the outskirts of the village because they are marginalized. In the town of Dutsenma, where I work, the locals refer to the Bori women as prostitutes, although I saw absolutely no evidence that they were such. It's sort of like calling a girl a slut while in high school to damage her. The Bori use spirit possession. They treat a variety of illnesses and misfortune, and two major infectious diseases that I've worked on that they treat for spirit possession are polio, a vaccine-preventable disease, and the debilitating leprosy. Nigeria is critical to the global effort to eradicate polio. Since 2003, Nigeria has accounted for a significant share of cases worldwide, and virus there has sparked epidemics worldwide. So why does this persist? Here we are waiting for the Bori. This is an area that has no electricity and still has no electricity. First, they persist because this is a really nice example of a syncretism where Islam has adapted itself to local conditions that are non-Muslim. These are two community workers I worked with who were interested in going. Everybody else was too afraid to see the Bori. There is performance. There are musicians. Hausa land is highly socially stratified by occupation, and musicians have low social status, and the ones who perform music for the Boris have lowest status. This is the Sarkin Bori. The king of the Bori finally arrives, and the show starts, and the performance starts in this case. It also persists because of the therapeutic power of the Bori. Muslims as well as non-Muslims believe in the efficacy of the curative powers of this group. And then they give these free demonstrations, and there's music, and everyone has a good time. So they're transparent in some of their activities, and lots of people want a good time in the far rural areas, including small hamlets. The women are marginalized, so the Bori women have a place of belonging. The performances promote solidarity, it reaffirms their obligations, and it bonds the Bori to each other and to the outside community. And so they persist, they have persisted, they are being driven somewhat underground now by the spread of Boko Haram in the area. They are not safe. Kano, they are still in the city, they're still in the city working, doing their jobs there. So here are the women that are older, very acrobatic, and there they go. Thank you.
Desert. If you're expecting a volcano, you don't see what I see, but it's in those white rock layers. And the reason you don't recognize it as a volcano is because not all of them look like this. This is a volcano in Ecuador. It's the most remote volcano, called Sangay. I was part of a National Geographic expedition in 2014 to go figure out if this volcano is active or not, or dormant. To get there, we had to travel 3 days across this type of terrain in the high Andes to get there. Once we get there, our job is to collect rock samples, lots of rock samples, so that we can bring them back to the lab. These are 3 of my colleagues on this particular volcano collecting rock samples, because this is where the answers are to the questions. All the rocks contain information, and we just have to know how to get the information out of the rocks to answer the questions. This is 2002, El Reventador in Ecuador. This took people by surprise. No one was expecting this eruption. 4 years later, the National Science Foundation funded an expedition led by me to go back to Reventador volcano and figure out what happened and if this volcano is still a threat. This is the volcano today. It is right now still active. As part of this expedition, we were able to take undergraduates from our department. These are both undergraduates who went on to get master's degrees. The one in the white shirt and the one in the hat are both were students, now part-time faculty for us. And what they're doing is working to collect the data. In order to get the data, we have to hire local guides to take us out to some of these locations. And so they get this added benefit of not just partaking in active research, but learning about the community and working with locals. This is another volcano in that same area. As part of that expedition, we had to get there by helicopter to get samples from the summit because it's 3 days through the jungle. And the information we're after, again, is in those rocks, and we have to get the rocks to answer the questions. We had 1 hour on top of this volcano to get our rocks and get down. Now, what does this have to do with the Mojave Desert? Turns out that volcanoes in the Mojave Desert, like these, right in your backyard, everybody, the Sima volcanic field. The questions we're wanting to answer is how often do these volcanoes erupt? When are they going to erupt again? How big are these eruptions going to be? And while these volcanoes are not particularly active, this tells a whole different story. This is a 20 million year old deposit of ash in my field area from the first picture. This tells us that there were big eruptions 20 million years ago in the Mojave Desert. It didn't look like this, and it wasn't those small little cinder cones. This was happening 20 million years ago, 3 hours from here. And what we are able to do is look at those ash layers and put together a story. We have to tell the story for the rocks. This is what we're looking at today, and this is a source for at least 2 master species that I've done with students. We have to get the rocks, and we bring the rocks back to the lab because this is what volcanoes in the Mojave Desert look like. And these are some of the minerals that we're looking at. This is zircon. We hit this with a beam of ions and some fancy mass spectrometers over at UCLA. And each one of those little spots tells us the age of the eruption, the age of the magma chamber. This is my student Edith Rojas. She's right here, now our part-time faculty. In the lab, we use fancy machines, and we produce lots of data. I could show you graphs, but we produce lots of numbers, and that tells us what we're after. Also, having a local research area means taking students to the field geology cannot be taught well in the classroom when we're dealing with the types of concepts that we're dealing with. We have to go here. Look at these students, not a single cell phone to be seen. And this is just another one of our field areas where we take some of our classes. These are our students, this is where they are learning, and this is also part of my field research area, so I can share that with them. Where do we stay? Well, sometimes we stay at the Desert Studies Center. You guys, CSU runs this center out near Baker. The LA campus is one of 7 that is in a consortium. This is one of our resources. Go out there and use it because you're entitled to it. And it's a wonderful place to, you talk about sequestering faculty and students for writing, go there. That's all I got.
Today about strategies of stigma neutralization among the ex-convict and the undocumented. What my research explores is how people react to the state branding them as criminals and illegal. This is sort of an exploration into bullying at the hands of the state. Sociologically, we contrast 2 means by which an individual status is degraded. Society degrades the status of people who engage in deviant behaviors because we regard them as choosing their deviance. The drug addict, the burglar, and the ex-convict are examples of persons whose status is degraded because of a perceived choice made by the individual which the rest of society deems worthy of degrading. Society degrades the status of people with deviant conditions because they are different. Their difference is found to be in certain respects unsettling. Examples of deviant conditions are blind, the obese, or those with developmental disabilities, as well as people deemed to be illegal. My research explores neutralization strategies on the pathways towards developing the soiled self as a master status. As criminal law becomes more like Jim Crow, immigration law has become more like criminal law. I argue that the master status of illegal and ex-convict are mirroring stigmatized identities. My research explores how people react to these labels to construct a more positive, pro-social self. When examining prisoner reintegration, we look at how ex-convicts neutralize the stigma that is assigned to their identity. In light of 3 major strategies of stigma neutralization, these are concealment, avoidance, and deviance avowal. When examining prisoner reintegration, ex-convicts can sometimes try to conceal their status degradation in ways mirroring persons with undocumented status. Ex-convicts can try to keep their soiled identity from being public, but it is difficult in respect of looking for employment, looking for housing. For female ex-convicts, the pathway towards developing a pro-social self functions through the strategies of deviance avowal, rejecting their formal stigmatized self in favor of socially favorable identities of motherhood and sobriety. For the undocumented, the pathways towards stigma neutralization are a bit different. There are 2 categories of people who grew up undocumented in Los Angeles. These are the early exiters and the college goers. For both, adolescence is an important time when stigma of illegality begins to leave its mark. Undocumented and ex-convict are forced to confront a world filled with invisible punishments and the pathways towards stigma neutralization. In fact, for the formerly incarcerated, technical parole violations are the #1 reason for returning to prison. For the family of the incarcerated, their outlook on daily suffering is marked by efforts to redefine their stigmatized self in a positive light, to construct trajectories that position them as moving forward. For the undocumented, illegality as master status means that their daily lived experience is defined by persistent liminality. Threat of deportation conditions their interactions with basic everyday social institutions. Life at the margins for both undocumented and ex-cons requires a precarious balancing act. On the one hand, agents demand recognition by their stubborn refusal to live life in a cage, seeking to enjoy a life that isn't determined by status. On the other hand, their accounts of daily suffering are filled with statements like, "It makes me sad. I moved like 10 times when I was 4 to 14. Real life is different. Our preoccupation, our fear is to be caught." How best to react to state branding? Sociology can be used as a tool to resist domination. Activism matters. We can resist state branding through litigation in courts as well as through simple rearticulation of illegality or ex-convict as identities of non-exclusion.
I gotta stay focused. Okay, so I'm Deborah Garcia. I'm a lecturer, part-time faculty of both psychology and the Charter College of Education, and this is my proposed research on predictive and moderating effects of non-cognitive factors on the academic stress per the college application and acceptance process. So as we know, getting into college reaps great rewards. Life is good with a college degree. We all know that. We all came to higher education institutions to get higher ed degrees, and we never left. We're still here, right? So as we walk into the classrooms on the first day, we're really excited and invigorated to share our own learning experiences with our students. We talk about all the different exciting things that we intend to do in class, like interactive debates and collaborative discussions. And after all this fervor, students inevitably raise their hands and say things like, "So how many questions are on the test, and how do I get an A in the class?" So we can feel the student anxiety in the classroom and in the process of learning in the classroom. They're anxious. And so much of this anxiety that we see in the classroom stems from earlier expectations of gaining access to college, where the focus is about GPA and test scores. We have 2 million high school students in the United States who take these tests and start really to question their self-worth, their ability, and their competency based on these scores and outcomes. This invariably leads to academic stress, where students perhaps start to believe that their worth as a scholar is just about a number. Competitive academics in American culture has really generated not only academic stress, but a significant amount of mental health distress amongst high school students, where 25% of these report clinical depression, and 1/3 rely on psychoactive substances to manage the distress due to the high-powered academic expectation to gain access to college. So researchers from MSU decided to explore some alternative dimensions that demonstrate student success in college just as much as GPA and test scores. And they analyzed the mission statements from 35 universities nationwide and identified personal dimensions of value to these institutions. And they found that these 12 non-cognitive dimensions did in fact have the same predictive qualities and college success rates just as much as GPA and SAT scores. So these dimensions fall on these interpersonal domains and deviate from the narrow criteria of GPA test scores typically used as the primary indicators of college success rates. And so these non-cognitive factors, again, which were culled from the mission statements of 35 colleges, are things such as adaptability and leadership and intellectual curiosity, multicultural appreciation, things that we care about in the classroom. And after several years of studying the validity of these dimensions as indicators of college success, they went back to the admissions deans from these 35 colleges and said, would you consider using these 12 dimensions in the admissions process? And each and every admissions dean said no. So unfortunately, we still have a fairly significant mental health crisis, particularly for high school students attending high academic rigor schools who take dozens of AP courses and struggle to meet the demands of high GPA and test scores to gain access to college. So the purpose of my study is to evaluate these 12 non-cognitive dimensions and determine their use in the admissions process, not as a predictor of college success, but rather as a way to possibly look at these dimensions to reduce the academic stress in high school seniors. So the study I propose is having 3 school studies nationwide. Schools have already been identified: Los Angeles, San Francisco, New York. Procedures will be an online survey looking at GPA test scores, colleges applied to and colleges accepted. Of course, the measures that I would be using are the 12 dimensions, the 12 non-cognitive factors. These are subjective inventories. Stress scale, a student rating of environmental stress. And what I wanted to know is really if we could look at these non-cognitive factors to help reduce this anxiety and stress. We already know that there's a strong positive relationship between GPA and test scores and academic stress. So I really want to find out and investigate using regression analysis how would these 12 dimensions possibly moderate the relationship that exists between these two variables. Essentially, I will explore if in fact these 12 non-cognitive dimensions weaken the association that exists between academic stress and GPA and SAT scores. I hypothesize the 12 non-cognitive factors will help to reduce that, and thus, if used for the admissions process, would reduce academic stress, reduce the mental health crisis in these students, help our students to be more present in the college classroom, and increase the depth of student learning for all of us. Thank you.
Department of Chemistry and Biochemistry. Today I want to share my research with you. My research is on materials. I call it next generation materials. The name is metal organic framework for these materials. Compared to traditional porous materials, it might be more familiar to you, the activist carbons and zeolites. They have been used in industry for decades, like as adsorbents, as catalysts. But these new types of porous materials I'm studying is has much higher surface area. Like 1 gram of the first materials made, I call it MOF, short for metal organic frameworks. The surface area is as big as a football field. So just 1 gram of these materials. So it's very high. And how we make these materials is to use a metal and an organic linker. And then they will self-assemble, like baking. You put it in the oven, they self-assemble to this three-dimensional structure. So I tell my students, they just know how to baking, then they know how to do research in my lab. So you can choose different ingredients, just like when you're baking, you choose different ingredients, and then you will make several different structures. There are thousands of structures already reported. And by making them with different linkers, then you can make the MOFs with different porosities. And also by adding different functional groups, you will have these MOFs with different functions for a variety of applications. So I built this house with a lot of advantages of MOFs. So these are just a few I listed. Because of all these advantages of these new materials, we can use it for different applications in industry, such as crystalline. So we can define the structure with X-ray diffraction. We know exactly where each atom is inside these materials. Just one advantage. There are other advantages, like you can make different structures by using different metal and nickel. And this is my lab's research. We are using these materials for different applications, including separation, like we can separate carbon dioxide from flue gas, and gas storage. Our university has a hydrogen fuel station. We can store hydrogen in this high porous materials, so we can increase the capacity of hydrogen in the gas tank. Others, like drug delivery sensors. And today I only share one story. One story of the many storage is catalyst. You know, this nerve agent, it has been used in the World War I, World War II, even was used last month in Syria. VX, right? Was reported by New York Times. So I will talk about how we use our research to decompose nerve agent and save people potentially. From the beginning, people used polymers to decompose this nerve agent. Just from about 2 years ago, 3 years ago, we started to use MOFs to decompose nerve agent. And we found by using MOFs, the decomposition time is much shorter. So the catalytic rate is much higher, is more efficient. So my research was to find better materials for degrading nerve agent and also master gas. Because we can use different clusters in this structure, like baking, you use different ingredients. So you can construct these different clusters, and these different clusters will have different efficiencies. The best materials we found, it can decompose nerve agent within 30 seconds. So 30 seconds. From the beginning, it takes hours, 60 hours to use a polymer that can be synthesized within months. But this structure, my student can synthesize within 1 week. So I don't even have to teach them a lot. Just tell them, just like baking, mix this, mix that, and put it in the oven. So we can use it as like a mask. This is another chemical weapon, mustard gas. We can also use our materials to decompose mustard gas. So there is another structure we found. Actually, it can decompose both mustard gas and nerve agent at the same time. Like within minutes, we're still improving it. Try to decompose both within seconds. So that's just the structure of the map it shows. This is my group. If you want to collaborate with me, that's my email. And these are all undergraduate students. So one of them will stay with me as a graduate student. So all the work we have been working on are done by the undergraduate student. Thank you.
I'm a third-year assistant professor in biological sciences, and today I'm going to give a little bit of an overview of our group's work where we model a disease called Leigh syndrome. So Leigh syndrome is a disease that usually manifests in children about 1 to 2 years old. They start out and acting completely normal, but after about 1 to 2 years of age, they start to show symptoms with very severe delays in motor control and mental abilities. And this is a neurological disorder that's called neurodegenerative and neurodevelopmental. The problem is that Leigh syndrome has a bunch of accumulation of lesions of dead brain tissue. And these lesions in the brain that you can see here are caused by defective mitochondria. We reach back to our high school biology. Remember that mitochondria are the powerhouses of the cell, so if the mitochondria are defective, they're not producing enough energy. It's a rare childhood disease, so research into Leigh syndrome is really difficult because rare childhood diseases don't have very much funding. It's hard to get tissue from them. All of these children here are going to die. These are recent pictures of them. They're going to die from slow asphyxiation to their brain tissue dying. So in order to look into Leigh syndrome and try to develop some cell models, because there simply aren't many of them available out there, we decided to look into mitochondrial biology. If you remember, mitochondria are these uniquely structured organelles within the cell that produce the most large parts of energy within our bodies. And this energy is in the form of ATP. If you look a little bit further into mitochondria, you'll see that there are a number of complexes studying this thing called the inner membrane within mitochondria. And these complexes are really what are responsible for producing all this energy in the form of ATP. However, in Leigh syndrome, we can see that a number of these complexes are compromised. And these compromised complexes result from mutations in genes encoding the proteins that make these complexes. And these compromised complexes lead to decreased energy. The decreased energy in the mitochondria has another effect, and that other effect is that it increases the amount of oxidative stress in cells as well. And the combination of decreased energy and oxidative stress leads to cell death. And the cell death in these brain tissues leads to Leigh syndrome. Actually, all of the tissues in the cells are in the patient's body are compromised, but the brain phenotype is the most striking. If you zoom in a little bit further, you can see there are 4 complexes that we just mentioned, ingeniously named complexes 1, 2, 3, and 4. And you can see here are some of the actual mutations in patients, the most commonly mutated proteins within these complexes in patients. So in order to develop a model of Leigh syndrome, our lab decided to go in and genetically delete each of these proteins that make up these complexes to try to recapitulate the syndrome. And that's what we did using a number of different techniques. And if you can see, what you see here are actually our results. And we, from these results here, try to get students excited about bar graphs, because that's what our lab's all about, lots and lots of bar graphs. You can see that we reduce ATP levels or energy levels by about 20 to 60% when we delete each one of these proteins. And that recapitulates the disease very well. That's what most patients have. And I'm not showing it here, but we also increase the oxidative stress, and we induce about 20% cell death in these assays, which really does mimic the disease quite well. So this is the first example of mimicking Leigh syndrome. But we wanted to push it a step further. We wanted to know if, in addition to producing Leigh syndrome in cells in a dish, if we can actually counteract it. So we spent some time looking for other proteins that might regulate energy production. We found this one called AK4. Don't have to worry about all the bar graphs here. AK4 is this protein that kind of acts like a brakes on cells producing energy. So we decided that if we thought if we could delete AK4, we might restore energy levels, and in fact, that was true. You can restore energy levels. Here's another graph depicting mitochondrial activity. We can restore mitochondrial activity, and we can increase the cell's ability to buffer oxidative stress. And so if we go in and produce our Leigh syndrome model, which is all these gray bars, and then on top of that perturb this protein called AK4, we can restore energy levels to normal or even bump energy levels up. So we found one method, first defined a method, by which we can counteract the actual cellular phenotypes of this disease, Leigh syndrome. And in addition to increasing energy levels, we found that we could also rescue cell viability, so we could actually cause more cells to stay alive in this context of Leigh syndrome. So here's just one example where there's a Leigh syndrome cell that we've created here. About 20% of these cells die, but when we knock down or reduce this AK4 protein on top of it, we can restore cell life. So this is our first foray into trying to produce both a model of a very understudied disease and identifying a potential therapeutic target for this disease. And of course, I just come up with some of the ideas, but there are lots of students in the lab who do all the actual work. See how fun it is.
Then they ask, what do you study? And when I say sea slugs, they say, dear God, why? So that's the question I'm going to try to answer today. Over the last 15 years, about 45 graduate and undergraduate students have contributed to this slide by sequencing DNA from 288 species of sea slugs that are collected from around the world. And using those data, we have developed this family tree, or phylogeny, that shows the evolutionary relationships of all of these species. And our goal is to try to identify the traits that explain why one genus on the right might have only a single species, but another one might have over 100 surviving species in it, because that's the measure of your evolutionary success, how many species have survived to the present day. And another goal of ours is to try to describe and name as many of these species as we can, because about a third of the species that we found in this group are new to science, and they don't have a name, which makes it really hard to talk about them and to work on their biology, because you have to just call them species 1, species 2. So all of these on the slide are new species. We're in the process of naming the one in the middle after Barack Obama, not just to troll Donald Trump, but that's a big part of it. We're naming one after Mr. Lucretz because I can be bought. So that's what we're doing. And what have we learned? We've learned don't be a clingy parent. We found that species that let their babies swim off into the ocean avoid extinction compared to species that keep their babies close to home. That got us on the cover of 2 journals because it overturned about 40 years of theory in marine science. We've looked at the influence of diet, and we found that species that have continued to exploit their ancestral seaweed food, shown in dark blue, do better in the long run, whereas lineages that have switched to exploit new diet sources have done well for a little while, but then they hit kind of an evolutionary dead end and they stop spitting off new species. So, tried and true, mom's home cooking works in the long run better than those newfangled fad diets that everybody's trying out these days. And then a third trait that produces evolutionary success is being photosynthetic. So some slugs eat seaweed, and instead of digesting it, their stomachs pick out the chloroplasts that do photosynthesis and keep them alive inside their bodies. So they become a fusion of plant and animal, and they can actually stop eating and just live on sunlight for months at a time. So think of the savings on your grocery bills if you just had to eat 1 salad a month and then sundaes. And so that fuels their success. So that's a reason you might care. It's just kind of cool and awesome. Some other reasons that you might care, that slide's not supposed to do that. So some other reasons that you might care about slugs are coming up in probably 12 seconds, maybe 8 seconds. I didn't think I'd have dead time. There are some anti-cancer molecules that have been isolated from slugs in my group called Elysia ornata. And I thought that name was being applied a little bit liberally, and so we've done some research on this group that showed that there are at least 9 different species that have been called Elysia ornata. And our lab is the only one in the world that can tell them apart, either using their DNA on the left, looking at the adults in the middle, or even looking at the color of the eggs that they lay. We can tell these apart, which is kind of important, because if you find a cure for cancer, you might like to know what species it came from. And at the moment, we just don't, because it could have come from any 9 of these species. And there may be new molecules that have anti-cancer properties in any of these species that haven't yet been surveyed, but because everyone's using the same name, we don't know it. Another reason you might care is there's a very evil algae that has taken over the Mediterranean, and the state of California spent $7 million eradicating an outbreak of this stuff called Caulerpa taxifolia. It's invaded Australia, it's invaded Japan, and nothing in the ocean eats it except some of my sea slugs, because it's extremely toxic and nasty. So we're studying them as possible biological control agents to help save the ocean from this awful, awful algae. Also, they're just really pretty. When most people hear slugs, the way that they connect emotionally is they think about the little bastards eating their vegetable gardens. What people don't recognize is that air-breathing snails and slugs are second only to insects as the most species-rich group of animals. There are more kinds of air-breathing snails and slugs than there are mammals, reptiles, amphibians, birds, and fish combined. So they're the silver medalists of all animals, which is an interesting question. How did they become so phenomenally successful? And to answer that, you have to know who their closest relatives are. And so we did some work in my lab that showed, unexpectedly, photosynthetic sea slugs are the closest living relatives of the air-breathing snails and slugs. So my lab is now doing research to try to understand the evolutionary transitions that allowed this lineage to get out of the ocean and onto dry land and to destroy your yard. Sorry about that. I want to thank the dean for organizing this, and I want to thank Kate for herding faculty. New band name, I call it.
Thanks to y'all who made this happen. This is really cool. So I want to start by telling you about this classic math problem that I learned about from our colleague Daphne Aliu. It's called the Hadwiger-Nelson problem. So you take the Cartesian plane, you know, the old XY plane, and you give every single point in the plane a color, like maybe green there, orange there, green again, like the table. But whenever 2 points are a distance 1 apart from each other, let's insist that they have to have different colors. And the question is, how can we do that with the fewest possible colors? Now it turns out you can do this with just 7 colors. And you paint by numbers, as in the picture that's about to come up with a bunch of, here we go. Now don't sweat any of the details. We're not going to follow details, it's too fast. We just soak up the flavor here. It also turns out that you do need to have at least 4 colors, as the next picture is going to show, because any 2 points there connected by an edge are distance 1 apart, and you can try at home with just 3 colors. You can't do it. It's impossible. So it's been known for over 50 years, you have to have at least 4. 7 doesn't work. Now, in math, when a question is too hard, we ask a different question. So here's a variation. What's the smallest number of colors you need to make every unit square, side length 1, a rainbow square? 4 different colors at each of the 4 corners. We'll come back to that. And meanwhile, here's a question from a nationwide undergraduate math competition a few years ago called the Putnam exam. So this time, we assign a number to every point in the plane. And we're going to insist that whenever you draw a square, the numbers at the 4 corners have to add up to 0. Well, one way to do that is easy. You just assign 0 to every single point. But the question is there any other way? And it turns out, no. And to see why, you draw this picture. That'll come up in a second. In that picture, ABPD forms a square. And so those 4 numbers have to add up to 0. Well, the same with every other square in this picture. You do some algebra, don't sweat the details, and you find that you have to have had a 0 at point P. That works for every point in the plane, and so every single point has to get a 0. Notice, by the way, there's no data, no experiments, no statistics, just logic. That's different between math and science. So in math, once you answer a question, you ask a new question. So our former colleague Richard Katz once asked, what about if it was the same question, but this time just at unit squares, the 4 numbers add up to 0? And it turns out, once again, the only way to do that is assign a 0 everywhere. But that logic's a little more complicated. We'll skip that. Back to our earlier question about can you make every unit square a rainbow square and with what's the fewest number of colors? I claim you cannot do it with just 4 colors. Because imagine you could. Everywhere there was a red point, you give that the number 3. Every other point you make a -1. So at a unit square, the 4 corners are going to add up to 3 plus -1 plus -1 plus -1 is 0. But 75 seconds ago, we learned that's impossible. The only way to do that is with all zeros everywhere. So 4 colors is not enough. Now, in the original Hadwiger-Nelson problem, we say that 1 is a forbidden distance. And in our variation of the problem, we say that 1 and the square root of 2 are forbidden distances. Now, it turns out that there is another forbidden distance problem due to Shela and Zoifer in 2007, where the answer to the question depends on the axioms that you start with. So in math, all of the logical deductions we make start with certain basic assumptions called axioms, and they're supposed to be non-controversial. Think of something like A plus B always equals B plus A, no matter what the numbers are. But if you start with something called the axiom of choice, then the answer is you only need 2 colors. If you start instead with a different axiom, this one, it turns out you need infinitely many colors. So same question, different answers. So even in the realm of pure logic and mathematics, and even when it's trying to answer very simple questions, the conclusions that we draw can depend on the assumptions that we make.